Hey everyone, let's dive right into this explainer. Today we're doing something a little bit different. We are actually going to bridge the gap between hard, technical math skills and the very foundations of our personal character. It's a fascinating concept that exists structurally right there on the coordinate plane, but also philosophically in the way we live our everyday lives. Yep, we're talking about reflections. Before we even touch a single number today, I want you to consider this really powerful proverb. As water reflects the face, so one's life reflects the heart. Mathematical symmetry is honestly just a perfect mirror, much like how our everyday actions mirror our inner selves. Just as a physical mirror shows us this accurate, unfiltered reflection of our face, our habits and our daily choices perfectly reflect what's truly inside our hearts. I want you to keep this idea of a perfect mirror tucked in the back of your mind as we start unpacking the math. Moving right along to Section 1, the magic of mirrors. So where does this concept of reflection actually live in the real world? Well, it turns out reflections aren't just dry textbook concepts. They literally help us understand congruence, orientation, and symmetry in practically everything. We're talking everything from taking a selfie on your phone to advancements in medical science. Think about it for a second. The symmetry in a gorgeous piece of classic architecture, the way computer graphics render perfectly realistic lighting in your favorite video game, or even how you use the side mirror on a car to merge on the highway without crashing, these all rely heavily on the rigid mathematical rules of reflection. Understanding this builds a way stronger grasp of how objects relate to each other across any given space. To put it simply, a reflection is just a perfect flip. The shape stays the exact same size, which is what we in the math world call congruence, but it faces the completely opposite way. It changes its orientation. If you walk up to your bathroom mirror right now and raise your right hand, your reflection raises its left hand, right? That boundary sitting right there in the middle, the mirror itself, is what we call the line of reflection. All right, let's get into Section 2, Rules of Reflection. Okay, so to translate that physical mirror into our mathematical mirror, which is the coordinate plane, we just need to memorize a simple visual difference. Reflecting over the x-axis makes the y value its opposite, while reflecting over the y-axis changes the x value to its opposite. Let's break this down together because it's super intuitive once you see it. The coordinate plane has two main mirrors. You've got the horizontal line, the x-axis, and the vertical line, the y-axis. If you jump across that horizontal x-axis, you are physically moving vertically, either straight up or straight down. That is exactly why the y value changes its sign. Conversely, if you jump across the vertical y-axis, you're moving horizontally, left or right, which is exactly why the x value flips its sign. Makes sense, right? Let's put this into practice in Section 3, Flipping Shapes and Points. Let's see how this all builds by putting those two golden rules to the test with some real coordinates. Say we take point A, sitting right there at 3, 4, and we want to flip it over the x-axis mirror. Well, our y value of 4 simply flips to -4. Notice how the x value, the 3, doesn't change at all? It stays exactly where it is horizontally, but vertically it takes a flying leap from 4 units above the axis to 4 units directly below it. That lands us perfectly at a brand new coordinate of 3, -4. Now, this brilliantly illustrates the y-axis rule. Starting with -2, 5, we flip the x value, bringing us all the way over to a +2, 5. This time around, our mirror is standing straight up vertically. We start on the left side of the y-axis at -2. When we flip across that vertical mirror, boom, we land symmetrically on the right side at +2. But the height, our y value of 5, it stays exactly the same throughout the entire move. Now, I know what you're thinking. What happens when you have a whole shape, like triangle T? Don't panic. Just apply our x-axis rule to each individual vertex, one by one, to reconstruct the mirrored shape. A triangle is literally just 3 connected points in space. So, point 1, 2 flips to 1, -2, point 2, 4 flips to 2, -4, and our final point, 3, 2, flips to 3, -2. You just connect those new dots, and there you have it. You've got a perfectly reflected, congruent triangle facing the exact opposite direction. Time for Section 4, Knowledge Check. All right, you've got the conceptual tools in your tool belt, so let's test your skills with a rapid-fire challenge based straight off your homework. Look at the pattern here. For point P and point R, crossing the x-axis simply flips the y values. For point Q, crossing the y-axis flips the x value. And for our triangle V down there at the bottom, the rule applies uniformly. Every single y value goes from positive to its corresponding negative opposite in one clean swoop. Honestly, once you focus on the movement pattern, reflections become incredibly intuitive. Now, here is a really fantastic conceptual brain teaser for you from the homework. What if a point is already sitting directly on the mirror? Where does it go when it reflects? I want you to imagine touching a real mirror with your fingertip. Where's the reflection of your fingertip? Right, it's right there, touching back against the glass. Let's see how our mathematical rules handle this exact situation. The answer? The point stays exactly the same. Because the y value is 0, it doesn't move at all, which perfectly proves how consistent our mathematical rules really are. If you're sitting flat on the x-axis, your y value is inherently 0. The mathematical rule for an x-axis reflection says we have to make the y value its opposite, but the mathematical opposite of 0 is literally just 0. So the math works out perfectly every single time. The point doesn't budge. Which brings us to our final part, Section 5, Mirroring the Heart. And now that we've totally mastered the mathematical mirror, let's zoom back out to that spiritual and philosophical mirror we talked about at the very beginning of our time together. The Smart Academy philosophy actually teaches that education intertwined with biblical morality is essential. Because, really, what is the point of being incredibly smart if you continually make bad choices that cause hurt? As outlined in their Godly Learners approach, simply accumulating a bunch of math skills and academic knowledge just isn't enough on its own. It's kind of like having a perfectly constructed geometric shape on a coordinate plane, but entirely ignoring the reality of what it's reflecting. Education without a mortar foundation can lead to a really hollow kind of intelligence, where you might have incredible technical skills, but character and empathy are severely lacking. As Romans 8:6-7 promises peace of mind to those who keep their minds spiritual, I want to leave you with this question to ponder long after this explainer ends. When you look at the symmetry of your own life and the choices you make every single day, what does your mirror reflect? Does your life reflect a heart of integrity just as accurately and perfectly as the x-axis reflects a coordinate point? Thanks so much for exploring this awesome intersection of mathematics and morality with me today. Keep seeking out those reflections, keep learning, and I'll catch you next time.